So for this video, we're going to be working on kinetic energy and linear momentum. So for this problem, we're given a 2100 kilogram truck traveling north at 41 kilometers per hour, and then it turns east and then accelerates to 51 kilometers per hour. So the first thing we want to do is to identify what the problem wants us to find. So the problem wants us to find the kinetic energy, the magnitude, and the direction of the change in its momentum. So now let's write down what the problem gives us and what we have to work with. So the problem gives us the mass of the truck, which is 2100 kilograms. It gives us the initial velocity, right, which is going to be 41 kilometers per hour north. So let's write that down. Let's put VI for initial velocity, and let's write 41 kilometers per hour north. Right, so let's make that a J hat. J hat just means in the positive Y direction, which is north. And then let's write our final velocity, which is going to be 51 kilometers per hour I hat. And I hat just means in the positive X direction, which is east. So now that we have everything that the problem gives us, now let's write down what we know. So we know that the formula for kinetic energy, which I'm going to denote as K, is equal to 1/2 times the object's mass times the object's speed squared. And we also know that the change in kinetic energy, right, let's denote that as delta K. Delta just means change. It's going to be the difference in the object's final kinetic energy minus its initial kinetic energy, right? So for its final kinetic energy, it's going to be the object's mass times its speed final, right? That means that the speed that it's going at when at the end. And then initial kinetic energy is going to be the object's mass, 1/2 the object's mass times how fast it's going at the beginning. So final kinetic energy is going to be 1/2 times the object's mass times how fast it's going at the end squared minus 1/2 times the object's mass times how fast it's going at the beginning. Right, so now this is going to be the formula that we're going to be using, delta K. And now let's finally just draw a diagram. So we know that the object is moving at 41 kilometers north at the beginning. So let's go ahead and draw our vector. Let's draw it over here. So here's our vector. Right, so the object is first going north. So let's draw that. And then at 41 kilometers per hour, right in the north direction. And then it turns east and goes 51 kilometers per hour. So let's draw this vector right here. And let's draw it a little bit bigger than 41 since it's going faster. And it's going 51 kilometers per hour. All right, so this is sort of a diagram of the truck's movement during this time period. And basically, we want to convert kilometers per hour to meters per second because we want to find the change in kinetic energy. And kinetic energy is gonna be in joules. And joules is equal to kilograms meters per second squared. Meter squared per second squared. And this is important because we have to have the same units for kinetic energy. So let's see. So let's convert 41 kilometers per hour to meters per second. So it's going to be 1 kilometer over 1,000 meters times 1 hour over 3,600 seconds. Right, so the kilometers are going to cancel out and the hours are going to cancel out because we're dividing those by each other. That leaves us with about 11.39 meters per second. So let's write that over here. That's right, 11.39 meters per second. And then let's convert. Let's do the same thing for 51. So once again, the kilometers are going to cancel out and the hours are going to cancel out. And that leaves us with approximately 14.17 meters per second. Right, so let's write that over here. So now we have our speed in terms of meters per second. Now, alternatively, you may have very well just plugged in kilometers per hour into our formula, and then you could have converted it into meters per second at the end. But I guess it just makes it a little bit easier to do it at the beginning and then plug it in so we don't have to do all that work at the end. So now we have our converted speeds. Let's plug them into the formula and then see what we get. So now we have delta K equals 1/2 times the object's mass, which is 2,100 kilograms, times the object's final velocity, which we calculated to be 14.17 meters per second squared, minus 1/2 2,100 kilograms times the initial velocity, which is going to be 11.39 meters per second squared. So if we do the math here, one thing we can do is to pull out the 1/2 and the 2,100 kilograms, because those are the same. We can just factor those out. So we can pull out the 1/2 and the 2,100 kilograms. Let's just pull those out. And then let's multiply. Well, let's do the math in the parentheses here with what's left. So we have 14.17 meters per second squared minus 11.39 Let me erase this. Meters per second squared. Right, so if we do the math in here, we get about 71. Let's call it 0.6 meters squared second squared times 1/2 times 2,100 kilograms. So now if we solve for delta K, we get $74.609 joules. Sorry, 74,609.64 joules. So this is going to be the change in kinetic energy of the truck.